Yeah, I'm gonna do some of these. I'm gonna start with force 7 because that's the easiest. The lhopitals. All right. You're supposed to plug in this number first and see if lhopitals even applies. L'Hopital only applies if the top and bottom go to 0 or infinity. You can see that in the directions up there. All right, so if I plug in 2, I get 0 on the top. It looks like a bunch of work here. Ick. So 24 minus 24. So that one turns into 0. They're all probably going to turn into 0. Just be that once in a while. They'll surprise you, try and trick you. Where it won't turn into 0, 0, infinity, for infinity. Sorry, okay, let's get going. All right, so to do L'Hopital's, take the derivative of the top and derivative of the bottom. So it's 1 over 9x squared minus 12x. Busy work, busy work. And then you try plugging in 2. So in the top I get 1, and the bottom I get 36 minus 24 plus 1, which is 12, which is 1 over 13. So I think that's the answer. I guess I skipped number 1. So you're supposed to plug in 2 into both and see if you get 0 over 0. So let's see, we get 4 minus 14 plus 10 over 0. It does look like 0 over 0. So then I take the derivative, 1, and then I plug in 2. So I get 14 minus 7 over 1. So 7. Oops, I got cut off. Okay, here we go. Number 3, I'll plug in 0 top and bottom. So 6 times 0, 0. Sine of 0 is 0. So yeah, L'Hopital's applies. So then I'll apply L'Hopital's derivative top and bottom. So it's cosine 6x times 6, right? Chain rule. Derivative of the bottom is just 1. Now that I've taken the derivative, then I'll try plugging in 0 again. So let's see, cosine of 0 times 6 over 1. Cosine of 0 is 1. It's 1. So final answer 6. Yeah, plug in 0 top and bottom. I get 0 over 1 minus 1. Yeah, L'Hopital's applies because it's 0 over 0. So then the derivative is 0. Derivative of cosine is negative sine. So negative sine is positive sine. And 2x. All right. And then I'll plug in 0 and I get 0 over 0 again. I plug in 0. Sine of 0 is 0. 2 times 0 is 0. So that means I apply L'Hopital's again. I'll take the derivative of top and bottom again. So I get cosine x over 2. And then I'll plug in 0. So I get 1 in the top and 2 in the bottom. So final answer 1 over 2. Number 5. So let's see, plug in infinity. So in the top I get infinity, and the bottom I also get infinity. So L'Hopital's applies. So I'll take the derivative 4x over e to the 2x times, it's chain rule, times 2. You might forget that derivative, but the derivative of e to the 2x is e to the 2x and then times the inner function's derivative, so times 2. Okay, so then I'll plug in infinity again. I still get infinity top, infinity in the bottom. So that's called indeterminate. That's not an answer, infinity over infinity. So I take the derivative again. I apply L'Hopital's again. So 4 on the top, and then the bottom is going to be e to the 2x times 2 times 2. And now I can see the top no longer turns into infinity, but the bottom still does. So that's 0 is the final answer. Tell us not the quotient rule. I don't know what this is asking. Used to evaluate each of this is not a limit. So to do the derivative of this is not a limit, so it's not lhopitals. This is just asking for the derivative, which is just quotient rule. So we'll do it anyway, I guess. So quotient rule for me, I do it fig VG. That's how I remember it. So the fig is f prime g. So derivative of the top is cosine 6x times 6. That's all just f prime and then times g. So that part's done. Minus out of frame here. Hang on a second. I'll just start over, except piece of crap iPad. It's not working, so I switched to my regular screen. So I was talking and there was no writing because, yeah, it's the iPad. Okay, so this one, the top and bottom are both infinity. I can plug in an infinity. I see the top is infinity, right? I don't want to write all that out, but it's infinity over infinity. So when I get that result, then I do lhopitals. So 4x over e to the 2x times 2. And now I try plugging infinity again, and I still get infinity at the top, infinity at the bottom. So I'll do lhopitals again. Derivative is 4. Derivative of this one is either 2x times 2 times 2. So then I plug in infinity and I get 4 over infinity, which is 0. Final answer. And this one, it's not lhopitals because lhopitals is just for limits. All the problems above were limits. This one's just asking me to take the derivative, which is quotient rule. So big VG. That's the quotient rule. So this part says derivative of the top, right? F prime. So that is cos 6x and chain rule times 6. So that's just the F prime, and then times G is the bottom. Okay, that part's done. Minus F times G prime derivative of the bottom, which is 1 for x squared. And if your teacher doesn't make you simplify, you could just leave it like that. If he does make you simplify, maybe clean it up a little bit. You can put parentheses here if you want. Squared, and the x's don't cancel, so that's just it. Okay, do some more. 0 in the top and 0 in the bottom, which is most likely how all of them will go, but technically, I guess you have to check. All right, derivative of the top is 1, derivative of the top is 2x minus 3. Then I plug in 1. I get 1 over 2 minus negative 1, so final answer. I'm trying to go super fast because I don't want to do homework. I don't care about this. So I'll likely make a whole bunch of mistakes. So check the answers with your answer key. All right, bottom turns into 0. 25 plus 10. This one, I don't think I'm getting 0 on the top, am I? I better check it. 25 plus 10 minus 35. It is 0. I'll plug in negative 5. plug in 0. So I get 0 over ln of 1, which this is 0. You should probably don't know that. I don't know. But you're supposed to know it. You can punch it in your calculator if you want. Okay, so I took the derivative. Top is easy, 4. Bottom, you might have forgotten that one. It's 1 over x plus 1 times the derivative of the inside, which is just 1, so I don't need it. It's a little bit weird. So to simplify that, I'll put this over 1, and then it's a multi-tiered fraction. I'll do keep change flip. 4x plus 4. And then I'll plug in 0. So I get 4. All right, do I want to do all these? I'll skip. See if I see some weird ones. So hopefully you're able to do the derivative of that. It's going to require a chain rule. That doesn't look too hard. This one maybe is weird. I don't know. I'll plug in 0 first. 0 on the bottom, 0 on the top. To do the derivative of this, I want to rewrite it as 4 plus x to the 1/2. Now when I do the derivative, this is like a chain rule. So I bring the 1/2 down and then reduce this by 1. Derivative 2 is 0. Don't need that. Derivative of the bottom is just 1. Okay. I guess now I'll try to plug in 0. 4 plus 0 is 0, negative 1/2. And the bottom is just 1, so I won't even write it. And this thing becomes 1 over 4 to the 1/2. Right, because the negative. And 4 to the 1/2 is just the square root of 4. So this thing becomes 2. So 1 over 4, final answer. That's one way to cheat this thing, especially if you have your calculator. You could just plug in a number that's really, really close to 0, like 0.0001, especially if you have your calculator. So it'd be 4 plus 0.0001. That's 2 over 0.0001. I guess if you did this, you'd probably, the calculator would spit out some answer like 0.24999. Or maybe it would just be 249. I guess you'd have to, it's not a slam dunk, but you'd have to go, oh, that's getting closer and closer to 0.25, which is 1/4. Might work. So I'll do number 14. So if I plug in infinity, yeah, I get infinity over infinity. All of them are passing that test where I just check if it's top and bottom or 0 infinity. So like I said, it's just once in a while that the problem won't have that. So if there had been like not that one, minus ln of x here, then I wouldn't be able to tell. On the top, I would kind of get 0. On the bottom, I'd get infinity. So then I'd have to say lhopitals doesn't apply. If I get 0 over infinity, then I say, oh, lhopitals doesn't apply. Probably not going to happen. You're probably just going to go straight into doing the derivative. Okay, derivative of ln is 1 over. Since it's a function inside, I have to do the chain rule. Derivative of ln is 1 over. And since it's a function inside, not just x, I have to do the derivative of that, which is 3x plus 4 to the second times the derivative of the inside, which is just 1. All right, pretty icky. Let's see. This simplifies to 2 over x. And these cancel. I get 3 over x plus 4. This one's pretty tough. Maybe if you got this on a test, you just skip it. So I'll do keep, change, flip. Okay, so here I'm still getting, I plug in infinity, I still get infinity over infinity. So I have to do the derivative again. So I'm going to get 2 over 3 after I do the derivative. So that's going to be my final answer. Let's see, if f of x equals that. I guess I'll just plug these in and see what happens. F of 0 is just 5. 2x to the third, x to the third, which is just 2. Okay, so I didn't even need lhopitals. Guess I wouldn't worry about this question. This is like some kind of bonus question, or really difficult, so probably not worth going over. But they're describing these two functions that sounds like the two functions at x equals 3. They're verbally describing some situation like got some line, 1/2. Something like that, this line that they're talking about. Then they're saying two graphs are both tangent to this line, so maybe there's a graph like that that's tangent, and maybe there's some other graph that, I don't know, it's like goes like that. I don't know what they look like at all because they don't describe it, but they just say that the two graphs are both tangent and the graph of h. So that's most of the battle, just interpreting what they're even talking about. Since both graphs are tangent there, that means the slope on either graph is equal to the slope of the line, which is 1/2. But AB function given right expression is totally separate. So this is another conceptual question, but they want you to do the derivative of this, which requires product rule. You should probably just skip this one. Find A. So then you plug in 3 to both of these. And then h of 3, which they told us up here is 5. H prime of 3, I guess we figured out. I'm not going to plug that in the calculator. I'm going to skip C. I don't know, some other. Yeah, 4.2 position, velocity, acceleration. The velocity is the derivative of the position. So you want to memorize that. The velocity is the derivative of the position. So they gave us a position equation, and they're asking us for the velocity. So that means we take the derivative. The acceleration is the derivative. See. So that's how you do it with the equation. With the graph, I guess you could do this and then just graph this, which is going to be a line at 18. It's going to go down about 10 every second. Something like that. I guess if I want to get this point accurately, I could plug in 0 for b. See, it would be 18 divided by 9.8. Alexa, what's 18 divided by 9.8?
18 divided by 9.8 is approximately 1.8367.
So 1.8267. So something. And the acceleration, so just like that. Flat. So let's say if the velocity is negative, then the particle is moving down. It's going up. Velocity is 0, it means it's stopped. That'll be this point when the ball reaches the maximum height, it changes direction, it's going up and then it's going down. So for that moment, the velocity is not up or down, it's 0. Average velocity. What did he tell you how to figure that out? I don't know. There's another one. Average. He's asking average velocity somewhere else during the first 2 minutes. So have to think about that one. Velocity. Yeah, I remember. The average velocity between any 2 points, which they didn't give 2 points, but I guess we just assume they mean from 0 to whatever time that is. This is going to be just the slope of that secant line. So I don't know, but it's not, I don't know if they're even asking, but so to do that, we'd have to find this where it hits the ground. So we'd have to set the height equal to 0, the position equal to 0, and find that time, which I'm not going to do, but certainly doesn't factor. You'd have to plug that into quadratic formula or use a calculator. I'll just guess that it's like 3.7 or something. So to find this, the average velocity, you're doing the slope, y2 minus y1. All right, so y2 is 0, y1 is 2, and x2, I'm just guessing, is 3.7, 0. So it's about negative 2 divided by 3.7, whatever that is, which would be some small decimal. It's going to be like negative 0.5 or something. And the speed is the absolute value of the velocity. That's just a thing. Yeah, speed can't be positive or negative. It's just always positive. So even if the velocity of the ball was like negative 3 feet per second, the speed would just be 3 feet per second. If velocity and acceleration have the same sign, then the particle is speeding up. It's just something I just memorize. And if they're opposite, then it's slowing down. Just memorize that. All right. What is asking? Conclusion. So I think they're just asking you to determine whether it's speeding up or slowing down. So opposite signs slowing down. Displacement. I mean, what are they? They're not clear what they're asking, but displacement is change in position. Think about what they're asking here. Yeah, I'm not sure exactly what they're asking, if it's a number or concepts, but just read your answer key. But displacement is change in position. There's other definitions, but I don't think you've learned that. Did you guys do any antiderivatives? This is uh, I guess just this would be another definition of displacement. But I don't know if you guys learned that. All right, keep going. Displacement. First 2 minutes. Okay. Yeah, displacement is just change in position. So I guess we'll go with that one. Change in position. So for the first 2 minutes, we can use this equation to find the two positions. Let's start with the initial position at time equals 0. So 0 minus 0, 3. So x of 0, the initial position is 3. And after 2 minutes, same thing, we plug 2 in to get the position after 2 minutes. So we get 8 minus 16 plus 3 equals negative 8 plus 3. So negative 5. So the change in position, it went from 3 to negative 5. So one way to calculate is do the x final minus the x initial, which would be negative 5 minus 3. So the change in position is negative 8. Right? It started at 3, and then it moved backwards 8 units and arrived at negative 5. Find the average velocity during the particle. So we said average velocity is just x2 minus x1 over time 2 minus time 1, which is, it's the slope, right? I know I'm using x there, but for this, x is the y. X is what we use for position, sometimes s. All right, we actually already calculated the top of that last step. It's negative 5 minus 3 is negative 8. And this is 2 minus 0. So the average velocity was negative 4. I guess I should put units. Centimeters per minute. This was in centimeters. So this is find the actual velocity, which means we take the derivative. Then plug in 4. So yeah, 16 centimeters per minute. So you'd think these would be similar, but nope. So this is just an instantaneous velocity. If I graph this thing, it's going to be some wild, it's a third order. I don't know what it's going to look like. some wild looking thing, something like that. So this is just some velocity at some certain point. Should have been negative 16. It's like there, it's got a slope of negative 16, but the average velocity is something a lot gentler, whatever. They will not necessarily be similar. Okay, acceleration is the derivative of the velocity. So take the derivative of that to acceleration. Then I'll plug in 4. This one's centimeters per minute squared. Acceleration is distance per time squared. This particle speeding up or slowing down. So it looks like they're opposite signs, so slowing down. Shows the loss. Moving right. All right, so this is a graph of the velocity. Sometimes they'll give you a graph of the position. And that changes your interpretation, of course. All right, so it's velocity. So it means at this point, for example, this indicates a positive velocity because it's above the x-axis. And this point is a negative velocity. And a bigger negative velocity, smaller, 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 and it eventually gets to 0 velocity. And then it changes direction towards positive velocity. Positive, positive, positive. So if this was a car driving on this road, starting at this time, let's see, it starts right here. See that's 0. This car, for the first 1 second, it's moving really fast in the negative direction. Well, it's moving, and then slowing down to, it's going, see this line? Oh, it slows down right there and it stops. So that would be this point right there. That's 1 second it took. And then what happens is it starts gradually, slowly moving up. Let me back up. I screwed up. Okay, here's the car. It starts at 0. I messed up. This is a positive velocity. So it's moving in the positive direction quickly when the clock starts. So it's going like this. And slowing down. And then right here, when it changes direction, slowly going backwards and speeding up until it gets right here, maximum speed, and then starts slowing down till after 4 seconds it stops and starts going back the other direction, speeding up. Then at this point it starts slowing down again. Then it stops. Okay, so it moves right, and then it moves left, and then it moves right again. All right. When is the particle moving right? From 0 to 1, not a bracket, it's always open, and 4.5 to 7, not bracket. The acceleration is the slope of the velocity, just like the velocity is the slope of the position. So this is a negative acceleration, positive acceleration, negative acceleration. So 2 to 6. It's positive. When is the acceleration 0? Anything would be these points, but there's since it's a corner, then we can't say the acceleration is 0 at that point. It's undefined. It's the only way. If it had been like a smooth curve like this, then the acceleration would be 0 right there because it's got a smooth 0 slope. But here we can't say the slope is 0 because it's a corner. So TNE for that one. When does it have the greatest speed? So it looks like this is the greatest slope if we're not accounting for the sine. This is the lowest speed, I guess, because it's, let's see, it's a negative 4/2. It's a negative 2 whatever units is the velocity here. And this one is 4/3. So 1.333, but it's positive. And then this one, it's negative 1/1. So -1. So this is the biggest velocity, but this is the biggest speed. So from 0 to 2, the speed is positive 2 whatever units, inches per second or whatever. When is it speeding up? That's when the acceleration and the velocity have the same sign. So let's see. Acceleration is positive from 2 to 6. And the velocity is also positive from 2 to 6. So from 2 to 6. Should look at this one. Oh no, I'm screwing this up. All right. I'm going to go in this region. So on this one, the acceleration is negative on the whole thing. It's -2. But only in this region is the velocity also negative. So from 1 to 2, the velocity is -2. And the velocity is negative. I'm sorry, I said that wrong. From 1 to 2, the acceleration is -2. And also the velocity is negative. So that means it's speeding up because they're the same signs. And for the same reason but opposite outcome, 0 to 1, it's going to be slowing down because it's a negative acceleration but a positive velocity. Zoom out on this. All right. So this one's a positive acceleration, but here we have a negative velocity. So from 2 to 4.5, they're opposite signs. And from 4.5 to 6, they're the same signs. This one's acceleration of 1.3. The velocity is positive. Here the acceleration is -1. And velocity is positive, so it's slowing down there. Justify. Particle moves along a line, so that's position. Instead of x, they're using s this time. The instantaneous velocity, so you take the derivative, t squared minus 6t plus 8. Yeah, so it's the answer is not a number, it's a function because they didn't give us a time. But if they said at time equals 1, then we would plug 1 in and get a number. When's particle at rest? That means the velocity equals 0. So we'll take our equation and set it equal to 0. And you'll either have to factor or quadratic formula. So I get probably factors. So t equals 2 and 4. The velocity is 0. Acceleration is the derivative. displacement of the particle for the first 3 seconds. So time equals 0. It's -5 is the position. And at 3 seconds, we'll have to plug that in. Nick. Yeah. 7 over 3 is 9. Wait a second. 9 minus 27. Math. Yuck. It's 5. So that's -18 minus 24. So much work. Minus 42 minus 5 is -47. Probably made a mistake trying to rush, but so the displacement is final position minus initial position. So in this case, it's minus 47 minus 5, so it's -42. Better check that one. All is dropped to him in the head of all. Just head of all. So this is the velocity ball. Obviously, we want to do the derivative. So -32t is the velocity. Then they want us to plug in 3. So 32 times 3. And don't forget the units. They give it feet per second. What does it mean? It's just the velocity of the ball, how fast the ball is dropping, I guess. So it's dropping. Second derivative. That's feet per second squared. Explains what it means. The ball is always accelerating at the same rate, -32, no matter what the time is. Velocity at 0. So this is getting more difficult, I guess. It's calculus, so pretty much always taking the derivative. And they said when the velocity is 0, so set that equal to 0. It's like a 3 factors out, and it's factorable. So t equals 1 and 3. And they're actually asking for the acceleration. So you'll derivative again, 6t, 12, and then they want you to plug each of these numbers in. The acceleration. 6. Particle P moves on number line. So I have to read this twice and make sure I don't know if it's just the graph of velocity or is it position. It's really important to get that straight. But they said it's position. So let's write that here. So the other graph, I was like, oh, the velocity is positive, right? But this is not a velocity graph. This is a position graph. So in this case, the velocity is the slope. For example, the velocity from 0 to 1 is 2. And the velocity here, what's the slope there? 0. And so on. When is P moving to the left? Well, that would mean the velocity is negative. So here I have a positive velocity. Here I have a negative velocity, so 2 to 3. You could verify that. Here the position was 2, right? So the particle was all the way over here at 2. Then 1 second later, it was at -2. So that means it was moving to the left. Then it stopped for a couple seconds. It just sat there at -2, not moving. And then the clock started again. Once it hit 5 seconds, it started moving to the left again. Stopped at -4. So also 5 to 6, it was moving left. When was it moving to the right? Here it was moving to the right. It went from 0 to 2. Those times. I didn't write 0 to 2 because I'm reporting the times when it was moving to the right, not where it was moving, just the times. From 1 to 2, it was steady. Its velocity was 0. And I guess we covered, that was the only time it was moving to the right. At rest, from 1 to 2, 3 to 5. Graph of the particle's velocity, where defined. Okay. Switch. So here the velocity is 2. So I could do this on the same graph or separate graph. I'm just doing it on the same graph. I'm lazy. So it's like that. And I guess you should maybe put an open dot there. So the velocity at the corners is undefined, right? I can't gauge the slope there. All right, from 1 to 2, it was 0. And then it was -4. Then it was 0. The slope of this one was -2. All right. So you might notice that lines up with our answers from 2 to 3 and 5 to 6. It was moving left. In other words, the velocity was negative. So that kind of jives with that answer. Just velocity. So this graph is velocity again. We gotta be careful with that. Know what the graph is. So this is the one where it's like, oh, the velocity is positive, velocity is 0, velocity is negative, velocity is -2. So this looks like where the particle stops, but no, the particle is just moving at a constant rate to the left. So on the velocity graph, these points are when the velocity is 0. That's important to know. When does the body reverse direction? Well, here the velocity went from positive to negative. So at time equals 2, not this one, time equals 7.75. The velocity was negative and it turned positive. And here, I guess the velocity hit 0, but it didn't reverse direction, it just stopped. So I think those are the only 2 points. Constant speed, that's the only place. The velocity is -2 during that whole interval. Body's maximum speed be, so you could say 9, but it's actually 6. Velocity is -4 here, and it's +3 here, but the speed is the absolute value. So the speed is 4 meters per second. In terms of speeding up, so speeding up means the velocity and the acceleration are the same. So here's a positive velocity and the acceleration is the slope, so that's speeding up. Here the velocity is positive, but the slope is negative, the acceleration is negative, so that's slowing down. Here the velocity is negative and the acceleration is negative, so that's speeding up. Same sign, it's speeding up. Acceleration is 0 there, so that's not it. 4 to 6, speeding up, it's negative velocity, negative acceleration. Positive acceleration, negative velocity? Nope. Positive velocity, positive acceleration. negative acceleration, positive velocity. So it's out. Turn vertically over the surface. It's velocity acceleration. You know that one's derivative. And acceleration is derivative of that. It's negative 1.6. I'm going to take the rock to reach its highest point. So the rock position graph looks like this. And this is the highest point. This is where the velocity is 0. So whenever they're asking to find the maximum or minimum, whether it's these particle things or something else, whenever they ask for max or min, take the derivative and set it equal to 0. So they are asking us for the max. So we take the derivative, that thing, set it equal to 0. And here we get 0. Just double check that. All right, it's good. I was just paused when I thought I wasn't. I gotta go back. So yeah, it's not t equals 0 because I made a mistake over here with my derivative. I treated 32 as 32 instead of 32t. So the derivative should have been 32 minus 1.6t. Which changes this. So I take my derivative, 32 minus 1.6, and I set that equal to 0. When I do that, I get, is it 2? No, it's 20. Making all sorts of mistakes. Negative 32 over 1.6. There's a 20. Right? Okay. And then I got to reread my question to make sure I'm answering what they're asking for. Let me reread it. How long? Yeah, the time. So that's the answer. Because sometimes they'll ask you, what was the maximum height? You would still do this process. You'd find the time first, but then you have to do the additional step of actually plugging it back in to calculate the actual height. All right. I don't table is like a time lessons. Yeah, we'll try to keep going. I'm getting tired of math today. I got a lot of kids today. Did in table because so left. So table first, moving to at rest. Yeah, if there's any change in direction, that means it had to stop momentarily. So at some time between 0 and 2, the velocity changed direction. It was traveling backwards and it changed to moving forward. So somewhere in there, it must have stopped for a second to change direction. So is there a time during the time interval? Yes. Time is between 0 and 2. There was a change in direction. Of velocity. I'll just say direction. All right. In other words, a change in sign of the velocity. It's the same as a change in direction. Use that from to approximate velocity at 10. So 10 is at this interval. when they say approximate velocity, is that an approximate velocity? I thought we were going to do the slope, but no. So I'm just going to say 6. So that's between 7 and 5. But usually, if they're asking for the approximate, usually that means we're taking like the slope. So it'd be like 12. That would be 5 minus 7 over 12 minus 8. But that would be an approximation of the acceleration. Try not to get too deep into that. Yeah, I'm not explaining that very well because I'm just trying to rush through it. Choose a particle motion. Oh, it is that. I screwed up. I got confused because velocity is the derivative of position, but this is actually asking for the derivative of velocity. So what I approximated was just the velocity at 10. The derivative, approximating the derivative, that is that slope equation thing. So it is 5 minus 7, right? Y2 minus Y1 over X2 minus X1. So the derivative of velocity is acceleration. So this is an approximation of the acceleration on that interval. So it'd be meters per minute squared. So I guess I would just say that derivative of velocity is acceleration. So b prime 10 is approximate of acceleration at t equals 10. It's pretty tough, and I don't know if you're gonna be able to prepare for this thing. And then these might even be hard. I'm gonna skip that last one and try and do a couple of these related rates. Word problems, right? So that's gotta be bad. Try to do a couple. Rectangle. And in these word problems, each dimension like this, I've got length and width, so I'll just call this x and y. But each dimension is going to have two numbers. It's going to have x, and it's also going to have the rate of change of x. I got y, which is the size of this, but I'm also going to have how fast y is changing. So we'll kind of try to build that as a theme in the next problem. So you draw a shape, and there's always, you can have two things associated with each side. All right. The width, which I called x, is increasing at a rate of 2 centimeters per second. So increasing means plus. So dx dt is the rate, 2 centimeters per second. And the length is increasing, so 3 centimeters per second. What is the rate? The area is increasing. So whatever they're asking for, like here I've just come across that. What is the rate of the area? That tells me, oh, I need to get the area equation. Just like that. No, I won't put x's or y's in it yet. I just know like that's the equation for the area of a rectangle based on side. Okay, and then I keep reading, they give me some more numbers. So the width is 4 and the length is 5. Okay. Once I get the equation for what they're asking for, I'm gonna switch to x and y. And then Sometimes I'll try to get rid of one variable or not. Like sometimes they'll tell me like the width is twice as big as the height or something. I think I said that wrong, but and then I could substitute one variable to the other. But in this case, yeah, I can't get rid of either variable, so I'm gonna now have to do the derivative. This equation. It's gonna go like this: dA dt equals, and this is product rule. So do the derivative of the first one, which is not one in this case, not for these related rate problems. It's dx dt. I'll leave the second one the same. I'm doing like Fig Fiji. In this case. Yeah, I did this one already. Did the Fig. Now I gotta do the Fiji. So I take the first one, leave it the same. Do the derivative of the second one. So dy dt. So in this equation, I had three variables, but now when I've done this, now I have 1, 2, 3, 4, 5 variables. And it's at this point where I start plugging in numbers: the 5, the 4, the 2, and the 3. Okay. So dA dt equals, let's see, dx dt was 2, it's 5, x is 4, dy dt is 3, so 22. Since this is a change in area, the units for area are centimeters squared, but it's per time, so per second. That's my answer. Oh my god, I was paused all the whole time I was talking. Oh god, okay. I don't know where I stopped. Well, I think last time I paused, I was like wanted to check my numbers first. Go back a little bit. So I was rereading the question because I want to make sure I had all these numbers right before I do all these calculations. So the police car is at 0.6, and then they said it's 60 miles an hour, but I had to figure out which direction the police is going, but I had to reread the question. The police car is approaching the right angle, so it's going this direction, which means it's negative 60. And they told us the speeding car is getting further away at a rate of 20 miles per hour. So this should be a positive 20. If they had told us that the police car is gaining on the speeding car, like this distance was getting smaller, then I'd say it's a negative 20. But since it's moving further away, the distance is increasing. All right. And then as I'm plugging in numbers, let's see, x is 0.8, dx dt I don't know, so I just leave that as dx dt. Y is 0.6, so I'll plug that in. Dy dt is negative 60. And then I get to a point where I don't know z. So I have to come back over here and actually do Pythagorean to figure out z. This is 0.6, this is 0.8. I did that and it turns out to be 1. So just plug in 1. And then I'm going to stop there. This is just busy work, bunch multiplication, division. But I should get a positive number for dx dt, because I assume the car's, well, I know the car is moving that direction. So that might be like a sanity check. All right. Yeah, these are easier because it's related rates, but you don't have to do the big word problem. So for related rates, you're always doing dt stuff. It's always with respect to time. So let me do the derivative of this one. It's dy dt. It's not y prime or anything. Derivative of this is 12x to the third, but I have to tack on a dx dt. 6 dx dt. Now they're giving me some numbers. They're giving me x, giving me dx dt, which I'll plug in for both of those. And that'll leave me with looking for. Busy work, busy work. I'll just stop there. So these look kind of similar. Number 2 similar. And this is similar. So those should be doable. Much better than the word problems. Back to word problems. I'll do one more, I guess. Ika ice cube. Melting at a rate of 5. At what rate is the edge of the cube changing when the edge of the cube is 3 centimeters? So I know the equation we're interested in is the volume because it's melting at a rate of volume per hour. Cubic centimeters. It's volume. So I'm going to write out the volume equation for a cube, which is just side squared, side cubed. Once I have my governing equation, I take the derivative of it, dv dt plus 3s squared times ds dt. All right, now I've got some variables. 1, 2, 3 variables, so I can start plugging in numbers. So dv dt is 5. S is 3. Looking for ds dt. So it looks like ds dt equals 5 over 27. And I guess I should have looked at the sign. Since it's melting, that means it's decreasing at a rate of 5. Like the volume of the cube is decreasing, so I should have known this was going to be a negative. Which kind of makes sense because the side is, it should be shrinking, so it should also be a negative. So you could say it like that, or you could say the edge is decreasing at 5 over 27 centimeters per second per hour. So if you verbally say the edge is decreasing, then you don't put the negative. The decreasing is the negative. Okay, that's enough for today.